Pre-calculus. So these are your 2.3 notes for increasing and decreasing functions and average rate of change. They're probably actually your 2.3a notes. I'll probably do another set. In any case, first let's talk about increasing and decreasing. So we have a function here and we want to know when it's increasing and decreasing. So if I was a little guy like Mario and I was running from left to right across the screen, the increasing is when he would be running uphill. The decreasing is when he'd be running down, and then again we'd be increasing again. So if I want to say where he's increasing or where this function is increasing, I would say it's increasing from A to B. I'm going to use close brackets here because at these minimums and maximums, the function is both increasing and decreasing. So I'm going to include this point in both my increasing and decreasing intervals. It's increasing from A to B, and then it's also from C to D. So I'm going to union this with C to D. And then the decreasing interval is from B to C. And again, those are both closed brackets. Okay. Increasing and decreasing is nice. We're talking about slope, positive and negative slope when we talk about those. And in class, we've been talking a little bit about average rate of change. Remember, average rate of change is just the slope of the curve. And for this, we're going to use the function, or the formula, f of x2 minus f of x1 over x2 minus x1. So for the first problem, if I want to find the average rate of change for this function, x minus 3 squared, between x equals 4 and x equals 7, the first thing I'm going to do is write down the formula. So f of 7 minus f of 4, over 7 minus 4. Okay. It's going to be helpful to put the bigger number first. I'm sure that you've noticed that in the practice problems we've been doing in class, that if you have the bigger number first, you're going to reduce the number of negatives you're going to have to deal with. Now that I do this, I want to find f of 7. So I'm going to use square brackets to help me keep track of everything. Let's see, I need 7 minus 3 squared minus 4 minus 3 squared. And this is all over 7 minus 4, which is 3. Now I'm going to do my algebra here with PEMDAS. So 7 minus 3 is 4. 4 squared is 16. 4 minus 3 is 1. 1 squared is 1. And this is over 3. 16 minus 1 is 15. And 15 divided by 3 is 5. So on this problem, my average rate of change is 5. Now, on a test or a quiz, or even just to make sure that you know what you're doing, to check this, to make sure that you did it correctly, it's always a good idea to graph the original function. So I'm going to grab my graphing calculator, and I'm going to graph y equals x minus 3 squared. Now, when I do this, I know this is a parabola, and it's shifted 3 to the right because the 3 is inside the parentheses, but I can see that, if you're not sure, by doing x minus 3 squared. I should get a parabola that's shifted over, yep, to the right. So if I were to draw a sketch of this, see, I'm going to go over 3. That's where my vertex is. And then I know from my work over here that f of 7 is equal to 16 because when I figured out what f of 7 was, I got 16. So I know I'm going to have to at least go up to 16. So let's see. I guess if I make each one of these 5, then 16 will be just a little bit higher. So my parabola is going to go, let's see, over 4 is up 1. So like right there on either side. And then over 7, so 1, 2, 3, 4, 5, 6, 7 is up 16. And since parabolas are symmetric, I can put the rest of the points in that way. Now, if you have a hard time looking at your work to find out what f of 7 is and notice that it's 16, you could also get these points out of your xy table. So if I go in my table, I have the point over 0 up 9, over 1 up 4, right, over 3 up 0, and if I scroll down to 7, over 7 up 16. So if you have a hard time looking at your work, you can always look at your xy table to graph here. And now the average rate of change, remember, is just the slope between x equals 4 and x equals 7. So what I'm doing is when x equals 4, we're right here, And when x equals 7, we're right here. And I'm just trying to find the slope between those 2 points. Well, to verify, this is an increasing slope. So a positive slope looks right for my average rate of change. And then it looks to me like I'm rising, let's see, from 1 to 16, I'm rising 15, and I'm running 3. Notice that as we were doing our work, that's exactly what we got algebraically. We rose 15 and ran 3, rise over run. And sure enough, 15 divided by 3 does give us a slope of 5. So not only does the picture look right, it matches our algebra, which is good. Everything is copacetic. Just for a little extra practice on this, would you guys please, as a practice problem, do part B on your own? So you're going to find the average rate of change between x equals 5 and x equals 2. I want you to do it algebraically and then verify it graphically like I did above. Once you get done with that, so you're obviously going to have to pause the video to do that practice problem, we'll go on to example 2. So in example 2, we have an object being dropped from a tall building. The distance after t seconds is given by the function d of t equals negative 16t squared. And for this first part, they want us to find the average rate of change between t equals 1 second and t equals 5 seconds. Okay. So to do that, we're going to do d of 5 minus d of 1 over 5 minus 1. Okay. And then, let's see, d of 5 is a negative 16 times 5 squared minus negative 16 times 1 squared. And this is all over 4. 5 squared is 25, and negative 16 times 25 is a negative 400. 1 squared is 1, times negative 16 is a negative 16, but since it's a minus, we're going to get a plus 16 here. And this is over 4. So let's see, negative 400 plus 16, and then divided by 4 should give you a negative 96. And now if I graph this to see if it looks right, I'm going to go to my calculator. I'm going to plug in negative 16x squared. And I'm going to look at my xy table to just sort of verify my window. Since these are all pretty big numbers, I want to make sure that I get my graph and calculator window to be good. Since I want to go to 5, I want to make sure that I can see the y coordinate for 5, and it's going to be negative 400, which, by the way, is exactly what we got when we did it algebraically. So that tells me my window needs to go from 0, well, we know we have to go at least to 5, so maybe I'll go to 6. And then here from, now I need to have my min be negative 400, and that my max is probably fine. Since this is going to negative 400, I'm going to make my scale go by 50s. So you're getting a negative parabola. The parabola is opening up down, right? So I'm going to go ahead and sketch that here on my graph. So my parabola is opening up down, and this point we'll say is over 5 and down 400. This is the point 0, 0, and this guy must be at 1. Now again, if I don't want to have to figure out what 1 is, there's 2 places I can look. I can look, oh, actually 1 should be negative 16, because I got a negative 16 up here, or I can go into my table, and at 1, I'm at negative 16. So this guy's at 116. And then I'm finding the slope between these 2 points, the slope of the straight line, the secant line is what it's called. It's called a secant line when you connect 2 dots on a curve. And so then, sure enough, it looks like this slope is going down 400, or actually, sorry, down, not quite 400. What's the difference between a negative 16, negative 400, oh, come on you. So negative 400 minus a minus 16, come on, negative 400 minus a negative 16, there we go, is negative 384. So it went down 384. It ran 4, because from 1 to 5 is 4. And if you do the division here, negative 384 divided by 4 should give you negative 96. So negative tells me it's going down, and it tells me it's pretty steep. So here's your average rate of change. One last thing, on a problem that has units, for instance, this is distance probably in feet is my guess, over seconds. This is negative 384 feet per 4 seconds of time, which means this is negative 96 feet per second. So what this did was it gave us the speed of the object, because feet per second is speed or is rate. And so it means that this object that's falling from the building, after 5 seconds, or between 1 and 5 seconds, it's falling at negative 96 feet per second. So it's falling pretty quickly. And if you notice here, if I were to draw in these different slopes, the object starts falling slower in the beginning. It's still falling, but it's slower. And then as the slope gets steeper, it's falling more quickly. So it's accelerating due to gravity. Now, the last thing that we need to do is, this is going to be a little mimic of a calculus problem. So if we take our same function, d of t equals negative 16t squared, and we want to find it between a and a plus h, we're going to do the same math. So we're going to find d of a plus h minus d of a over a plus h minus a. Okay, so we're just plugging in the problem exactly as we've been doing it before. Now we need to go ahead and plug it into the function. So using brackets, I have negative 16 times a plus h squared minus negative 16 times a squared. So I'm just plugging it back into the original. On the bottom, a plus h minus a just leaves me with an h. Okay. And now this is where, this is sort of the reason why pre-calculus needs to be boot camp. Because in calculus, this is exactly where you're going to get, and you have to be able to do the algebra correctly in order to get the right answer, in order to be able to do the calculus. And so this is really the reason for pre-calculus being so tough sometimes algebraically, is that we need to be able to do this without sort of blinking. So to make this work, we have to follow PEMDAS. PEMDAS is key here, or order of operations if you want to use the correct terminology. Order of operations says I have to do parentheses first. So I go to the first set of parentheses and I say, is there anything in here I can do? The answer is yes. And then I go to the most inner parentheses inside there and I say, is there anything I can do? Now, a plus h, there isn't anything here that I can do because I don't know what a is and I don't know what h is. So then I have to make a decision between whether I do negative 16 first or I square. PEMDAS says that you do parentheses and then exponents, which means I'm going to have to square this first and then multiply by a negative 16. I think it's a good idea generally, guys, to work down your problem. And whenever you have to square something, I would do that off to the side somewhere. So I know that if I have to do a plus h squared, I know that's a plus h times itself. And I know that I have to FOIL. So a times a is a squared. I get plus ah plus ah from my middle terms, and a plus h squared, which means this is a squared plus 2ah plus h squared. I do my scratch work off to the side, and then I bring it back over here to put it back in my problem. So now I have negative 16 times a squared plus 2ah plus h squared minus, now in this set of parentheses, a squared is just itself, so I'm going to have negative 16a squared. So that was nice. And I still have an h on the bottom. Now I need to distribute my negative 16 into my parentheses because it's multiplication. So I get negative 16a squared plus negative 32ah minus 16h squared. And then a minus is a plus 16 a squared, and this is all over h. Okay. Now I get to the fun part. If you've distributed your minuses correctly and you've done all the work up here, this is going to be a game of canceling things out and reducing. So I have a minus 16a squared and a 16a. Those are going to cancel. I get to negative 3ah squared minus 16h squared, and this is all over h. And then I have an h in both of these, so, oops, this isn't squared. I have an h in both of these, So I get negative, let's see, I'm going to pull the h out, negative 3a minus 16h, and then I can cancel. So my average rate of change is negative 3a minus 16h. By the way, in calculus, this is called the derivative. This is your average rate of change. And then the next step you would take usually in calculus is you would say let h go to 0. And so you would say negative 3a minus 16 times 0, and you would get negative 3a. Okay. So for our intents and purposes, we're going to stop right here, and we're not going to plug 0 in. However, for those of you going on to calculus next year, what you will do next, the calculus part of it, is that you'll plug in h equals 0, and this would be your final answer, which is kind of nice and neat, considering that this is where you started. Alright guys, that's it for tonight. Would you please make sure that you have everything written down, and that you did your one practice problem in here. And other than that, I hope you guys had a great weekend, or have a great weekend, and I will see you on Tuesday. Thanks guys.